Hello everyone and welcome to the next video in the series. This is a technical skills video on the topic of metric conversions. And when it comes to metric conversions, we have to talk about metric prefixes. These are prefixes that are used to generate larger or smaller units out of existing units. As an example, we can use the prefix K, which stands for kilo, to generate a unit that is 1000 times larger. Okay, let's take a look at what this means. The name of the prefix is kilo and the symbol for it is lowercase k. And the relation to the unit is that it creates a unit that is 1000 times larger than the existing unit. So for example, we could talk about kilometer, symbol km, and this is a unit of length whose size is the same as 1000 meters. We could talk about kilogram, symbol kg, and this refers to a unit whose size is 1000 grams. We can talk about kilomole, kmol as the symbol, and this is a unit of amount whose size is the same as 1000 moles. And we can do this with any kind of a unit that we have. We can even talk about kilosecond. Although we don't usually do that. Symbol for it would be ks, and this is a unit of time whose size is the same as 1000 seconds, and so on. Another example of a prefix would be c for centi, which generates a unit that is 100 times smaller than the existing unit. So as an example of this, for centi, symbol is lowercase c. Relation to the unit is that it creates a unit that's 100th of the existing unit. So we could talk about centimeter, symbol cm, and this is a unit of length whose size is 100th of a meter. We could talk about centigram, cg, whose size is 100th of a gram. Centimole creates a unit whose size is 100th of a mole. We could talk about centisecond, which would be a unit whose size is 100th of a second, and so on. Now, a couple of things is that number one, you cannot mix prefixes. So you cannot talk about kilo centimeter. And the second thing is that the resulting word is one word. So centimeter is not two words. It's just one word, no space between centi and meter. Casing in the symbol is of course important. Alright, now there is the important relationship between the numerical value and the size of the unit. And this kind of relationship is one that's inverse proportion. Inverse proportion problems are the kinds of problems where you have two quantities and the values of these quantities are related in such a way that if you multiply one of them by a number, the value of the other one gets divided by the same number, or vice versa. You divide the value of one of the quantities by a number and the value of the other quantity gets multiplied by the same number. So you double one, the other one goes down to half its value. Or if you multiply the value of one of them by 3, the other one gets divided by 3. And you could divide the value of one of them by 2, let's say, and the other one doubles, gets multiplied by 2. These kinds of relationships are called inverse proportion relationships. And as far as units and measured values go, if you divide the size of the unit that you're using by 2, so use a unit that's half as big, then you have to double the numerical value. Let me explain why. So here we have a line and we would like to measure the length of that line. And let's say that we're going to use as our unit of length this. This is 1. This is our unit of length. And if we use that as our 1, then we find that, let's say, 4 of them fit into this line. So the length of this line will be 4 units. Now let's say that we switch to the use of a different unit whose size is half as big. So now this new unit is half as big as the top unit. And we'll find that because it's a smaller unit, now more of them fit into the same length. In fact, twice as many. And we end up with 8 as the length. So you see, when I divided the size of the unit by 2, the numerical value got multiplied by 2. Now, of course, I could do that for any number. I could divide the length of the unit by 3, and then the numerical value would get multiplied by 3. Or if I double the length of the unit, then I will have to divide the numerical value by 2. And this relationship is something that we have with units, with the size of the unit and the numerical value that goes with it. The one that we care about a lot is 10, because in SI, each unit is divided into 10 units to create a smaller unit. So if you divide the size of a unit by 10, then you have to multiply the numerical value by 10 as well. And here's an example of what that means. So here we've got the same line. Let's say that this is our unit, and if this is the unit of length, then 4 of them fit. But if I divide the size of the unit by 10, if I make it 10 times smaller, so now this is a 1, then I find that 10 times as many will fit in, 40 of them. And this is in fact the case if the top unit was in meters and the bottom unit would be in decimeters. 1 decimeter is 1/10 of a meter. And in that case, if this is 1 meter, then the length would be 4 meters. But if I choose decimeter as the length, then I would have 40 decimeters. And this, of course, implies that if I want to go from meter to decimeter, I will have to multiply the numerical value by 10. Now you notice that meter itself is 10 times bigger, so going from meter to decimeter, we are dividing by 10. The size of the unit gets divided by 10, as you can see here. But when we say multiply by 10, it means that the numerical value gets multiplied by 10. And often we don't write the actual values, and we just say if you're going from meter to decimeter, multiply by 10. And by that we mean that the numerical value should be multiplied by 10. Okay, now we have the metric chart, and this chart I'm going to display it over here, and these are the prefixes that we have, at least the ones that are most commonly used. K for kilo, which generates a unit that's 1,000 times bigger than the unit that we are dealing with. H for hecto creates a unit that's 100 times larger than the existing unit. dA, both lowercase, stands for deca, which generates a unit that's 10 times bigger than the existing unit. Then there is one with no prefix, and this one, of course, is the unit itself. Then there is deci, which creates a unit that's 1/10 of the existing unit. There is centi. This one creates a unit that's 1/100th as big as the existing unit. And milli, which creates a unit that's 1,000th of the existing unit. And one thing you note here is that going from one prefix to the other, the size of the actual unit gets divided by 10. Kilo, divide by 10 to get hecto, the size of a hecto. Take a hecto, divide it by 10, and you get the size of a deca. And that means that going along this chart from left to right, the numerical values will need to be multiplied by 10. Okay, as an example of how we use the chart, I can use meter as the unit. And then I'll end up with kilometer, hectometer, decameter, meter, and then decimeter, centimeter, and millimeter. A kilometer is a unit whose size is 1,000 meters. A hectometer is a unit whose size is 100 meters. A decameter is a unit whose size is 10 meters. No prefix, meter, is of course 1 meter. Decimeter is a unit whose size is 1/10 of a meter. Centimeter is a unit whose size is 1/100th of a meter. And millimeter is a unit whose size is 1,000th of a meter. Now, I should also mention that this is not all that we have. In fact, the list of prefixes is a long one. The kilo, hecto, deca, unit, deci, centi, and milli. These ones are extended. On the right side of milli, the next two are not named, and then we have micro, which is 1/millionth. On the left side, and then there is more coming. On the left side, the next two are not named after kilo, and then we have capital M for mega, which means 1,000,000. And again, the list continues on the left side. After this, you have two more spaces that are not named, and then you have giga and so on. And the most commonly used part is this part from kilo to milli, and this should be memorized. It is very important that you memorize it. And in order to do that, in order to memorize that list, you can start, let me actually go back to the one that was just the units. Yeah, this one should do. Okay, so what I recommend is to memorize the list is that you go with 3 at a time. So sort of memorize the ones on the left, the larger ones, and keep telling yourself kilo, hecto, deca, or however it is that you memorize things. And then do the right side separate, deci, centi, and milli. Doing all 6 at the same time is a bit difficult, and don't forget the unit that's in the middle of it. Now there are some kind of reminders, I guess, that people use to remember them. So there is this kind of poem that goes along the lines of King Henry's daughter drank chocolate milk. I highly recommend that you don't follow these kinds of approaches, because apart from the fact that it's not professional at all, it's not professional sounding, it's also tough to constantly say King Henry, kilo, hecto. It doesn't work very well. If you just stick to memorizing the 3 on the left and then the 3 on the right side, that shouldn't be that difficult. Okay, and as I just mentioned, going from one of these units to the next requires that we either multiply the numerical value by 10 or divide it. If we go from a larger unit to a smaller unit, then we have to multiply the numerical value by 10. Now this can happen anywhere on this chart, of course. It could be the case also that I may want to go from one unit to one that's 2 steps down the road, or 3 down. And each step requires that we multiply the numerical value by 10, and that means that your decimal point basically moves forward over 1 digit. So if I'm going from kilo to hecto, I multiply it by 10, decimal point moves forward over 1 digit, and if I go to deca, then I have to multiply by 10 again, and decimal point moves forward over 2 digits as well. And again, the move can happen anywhere on this chart, on the metric chart. Let's say that I start with decimeter, and I want to convert the unit to centimeter. Again, going over 1 means that the size of the unit gets divided by 10, and so the numerical value has to be multiplied by 10. Now, of course, we can also go the other way. Let's say that I start with meter and I want to convert the unit to decameter. Now the size of the unit becomes 10 times larger, and the numerical value should become 10 times smaller. So we divide by 10, and decimal point moves back over 1 digit. The move can happen anywhere. It can start with meter to, and let's say that this time we want to go from meter all the way to kilometer. Then going from meter to decameter, we have to divide the numerical value by 10. Then going from decameter to hectometer, we divide by 10 again. And then from hectometer to kilometer, we divide by 10 one more time. So basically, the decimal point moves back over 3 digits, over as many digits as the number of moves when you move along the chart like this. Let's take a look at an example with an actual number. 25.89. I think I have it as one example over here. Yes, we want to convert 25.89 hectometers to meters. And basically then the question before us is 25.89 hectometers is equal to how many meters? And here we have our number 25.89. And let me, just as a reminder, put the metric chart at the top. Okay, now we start with hectometer here, and we want to go to meter over here. And therefore we have to move along the chart over 2 places. Each move requires that we multiply the numerical value by 10, and therefore decimal point moves forward over 2 places as well. So we end up with 2,589 meters. Now this is all fine. It's much better than having to convert units with, let's say, the imperial system, where 1 foot is equal to 12 inches, and you have to multiply the numerical value by 12, or worse, you may have to divide by 12. Either way, it's not as simple as SI, where we just move the decimal point back and forth. And this is, by the way, the reason that 1 kilometer is equal to 10 hectometers. Each of these larger units is 10 times bigger than the one next to it. This was done on purpose because it would map very nicely to the movement of the decimal point. Now you might say that, well, 10 is the most natural thing to use, and I would actually argue that that may not be true, because if that was the case, why is it that 1 foot is equal to 12 inches, not 10 inches? Alright, and all this is fine, this kind of movement, but still it's a little bit slow. What I have to do is if I want to, following the approach that we have here, to convert the unit from hectometer to meter, I will have to sort of find hectometer on the chart, find out how many places I have to move over, and then do the same with the decimal point. And this can take a bit of time. There is a better approach. What we do is we write the number that's given, 25.89, and then we associate the unit that it has, which is hectometers right now, to the decimal point. So where the decimal point is in your imagination, see hectometer. And then try to imagine the metric chart around it. Now you're going from hectometer to decameter and then to meter, and that means decimal point moves forward over 2 digits. So we start with hectometer, that's where the decimal point is now. Then we move it forward over 1 to get to decameter. And then we move it forward over another digit to get to meter. And so we get 2,589 meters. And the arrows are also not needed. All you need to do is just visualize the following. This is where hectometer is. And how do you know that it's hectometer going with the decimal point? That's the case always. The given unit goes with where the decimal point is. So this is where we have the hectometer, and then we move forward over 1 digit to get to decameter, and then we move forward over another digit to get to meter. So this is where the decimal point will end, and we get 2,589 meters. Okay, next we have 325 kilometers, and we would like to convert this to hectometers. So we write 325. Now remember that the given unit kilometer will be associated to the decimal point. So we find the decimal point, and that's here. This is where we put kilometers. And now we are going from kilometer to hectometer, and that means on the chart we have to move forward over 1. And that means we have to add a 0. So 3,250 hectometers. Problem 3, we want to convert 246 decameters to hectometers. So the problem is 246 decameters is equal to how many hectometers? We write 246. The unit decameter goes with the decimal point. So we find the decimal point, which is on the right hand, and that's we associate decameter to that. Going to hectometer, we have to move back on the chart over 1. and so we end up with 24.6 hectometers. Problem number 4, we want to convert 12.8 decagrams to decigrams. And so the question is 12.8 decagrams is equal to how many decigrams? And we write 12.8. Now this time the decimal point is given. That is associated with the unit decagram, the unit that's given. And going from decagram to decigram, we have to move to the right. We go from decagram to gram, then from gram to decigram. That means we have to add a 0 now. And we get 1,280 decigrams. And I've got one more problem, 94.7 centiliters to liters. So the question is 94.7 centiliters is equal to how many liters? We write down 94.7, associate the unit centiliter to the decimal point. And now we go from centiliter to liter. For this, we have to move to the left, from centiliter to deciliter, and then from deciliter to liter. So that's where the decimal point will end up at. We add a 0 before it, and we end up with 0.947 liters. Alright, the next topic is the metric chart for area. Now when it comes to area, and I think in order for me to explain how this works, I will give you sort of like a summary of what we got with length, because the concepts with length will sort of like generalize to area. So for length, we said that if we have a unit such as this one, which is 1 meter, let's say, and then we divide it into 10 parts and we get 1 decimeter, this, of course, we know that 1 meter is equal to 10 decimeters. And that means that going from meter to decimeter, we have to multiply by 10. Going back from decimeter to meter, we would divide by 10. So when it comes to length, a move on the chart corresponds to 1 movement of the decimal point. Now for area, we have this convention that if we have a square whose side length is 1 meter, so this side is 1 meter and this side is 1 meter, we refer to the enclosed area as 1 square meter. And of course, if we have a square whose side length is 1 decimeter, we refer to the enclosed area as 1 square decimeter. Now 1 square meter is the area that this square encloses. But keep in mind that the shape doesn't have to be a square. You could have some kind of a blob, and if the area that's enclosed by the blob is the same as the area that's enclosed by this square, we say that the blob has an area that's 1 square meter. And by that we mean that the area of the blob is the same as the area that's enclosed by 1 square meter, by a square like this one. Now the question is, how many square decimeters fit into 1 square meter? And to answer this question, we can fit one in a corner, and then we notice that 10 of them would fit in a row, because 1 decimeter is 1/10 of a meter, so 10 of these will fit in a row. But of course we have 10 rows. We have 10 small squares in the top row, and now we have 10 rows. So the total number of squares will be 100. And this shows that 1 square meter is equal to 100 square decimeters. And that means on the metric chart, when we go from square meter to square decimeter, we have to multiply by 100. Or if we are going back, we divide by 100. But then what that means is that for one move on the chart, decimal point moves over 2 digits. Okay, now here's the metric chart for area. Square kilometer, square hectometer, square decameter, square meter, square decimeter, square centimeter, and square millimeter. And now I would like to be very clear about something. Square kilometer, this notation means kilometer multiplied by kilometer. It does not mean kilo and then meter times meter. Kilometer is seen as one thing, so when you square it, is the whole thing that gets squared. You don't have to put km inside brackets to raise to the power of 2 to turn it into kilometer times kilometer. In fact, this other one is not one that we associate meaning to it, in the sense that it's not square kilometer. Again, square kilometer means kilometer times kilometer. Square hectometer means hectometer times hectometer, and so on. Alright, so on the metric chart for area, if you're going from square kilometer to square hectometer, we have to multiply by 100, and decimal point moves forward over 2 digits. Suppose we want to go from square kilometer to square decameter, then we have to make 2 moves. One goes from square kilometer to square hectometer, and the next one goes from square hectometer to square decameter. Decimal point has to move over 2 digits for each move on the chart. So decimal point moves forward over 4 digits. The moves can happen anywhere on the chart. As usual, if I'm going from square decimeter to square centimeter, I still have to multiply by 100, as square centimeter is 100 times smaller than a square decimeter. We may have to go back to the left. If we are converting the unit from square meter to square decameter, then we have to divide by 100 for that move, and decimal point moves back over 2 digits. Or we may choose to go from square meter all the way to square kilometer, in which case decimal point has to move back over 6 digits. 2 digits for each move on the chart. Okay, so for converting units of area, we move the decimal point back and forth, but this time 2 digits for every move on the table. As an example, let's say that we want to convert 250 square centimeters to square decimeters. So the question is 250 square centimeters is equal to how many square decimeters? And we're going to take the kind of shortcut that we had with length. Here we are going from square centimeter to square decimeter. We find the location of the decimal point, which is here, and we associate that to the given unit, square centimeter. Now to go to square decimeter, we have to move left on the chart. And for each move, of course, decimal point for each move on the chart, from square centimeter to square decimeter, decimal point moves back over 2 digits, and we end up with 2.5 square decimeters. Next, we have 1.78 square hectometer, and we want to convert this to square meter. So the question is 1.78 square hectometers is equal to how many square meters? We put the number 1.78 decimal point, we associate that with the given unit, square hectometer. Now to go to square meter, we have to move to the right. First we go from square hectometer to square decameter. Decimal point moves forward over 2 digits. Then we go from square decameter to square meter, and decimal point moves forward over 2 more digits. So let's add 2 zeros. And we end up with 17,800 square meters. And problem 3, we have 0.000425 square kilometers, and we want to convert the unit to square decameters. So the question is 0.000425 square kilometers is equal to how many square decameters? We write the number, and the given unit, square kilometer, it will be associated with the decimal point. Now, in order to go from square kilometer to square decameter, we have to go to the right 2 places. First, from square kilometer to square hectometer. Decimal point moves forward over 2 digits. And then we go from square hectometer to square decameter. And then again the decimal point moves forward over 2 digits. We end up with 4.25 square decameters. Alright, so that's how you work with area. Now the next topic is the metric chart for volume. And when it comes to volume, a cube whose side lengths are 1 meter is said to have a volume of 1 cubic meter. And if you have a cube whose side length is 1 decimeter, that would be the width and height and the depth, then we refer to the volume that it encloses as 1 cubic decimeters, or in this case decimeter. And now again, you don't have to have a cube to talk about 1 cubic meter. If you have, let's say, a jar, and the amount of water that fits in that jar is the same as the amount of water that fits into this cube, then we would say that the jar has a volume of 1 cubic meter. And by that we mean that the volume of the jar is the same as the volume that's enclosed by a cube like this. Alright, so now we want to find the relationship between these two cubes. We would like to know how many cubic decimeters fit into a cubic meter. And we fit one of these in the corner over here first. And then we notice that because 10 decimeters fit into a meter, we can fit 10 of those cubes along the edge. And now in the front face, we have 10 rows because 1 meter divides into 10 decimeters. Now each row can hold 10 of the small cubes. So there are 10 in the top row, and then there are 10 rows. And the total will be 100 on the front face. So 100 small cubes fit into the front face. And because depth-wise this is also 1 meter, we can divide it into 10 decimeters. Now each of these slices has 100 square or cubes in it. So there are 100 cubes here, and then there are 10 rows, and the total becomes 1,000. So 1,000 of these small cubes fit into the large cube, and that means that 1 cubic meter is equal to 1,000 cubic decimeters. And what that means is that on the chart, when we go from cubic meter to cubic decimeter, we have to multiply by 1,000, or if we are going back, we have to divide by 1,000. So that means that for every move on the chart, decimal point moves forward or backward over 3 digits now. Okay, with that in mind, here is the metric chart for volume. We have cubic kilometer, cubic hectometer, cubic decameter, cubic meter, cubic decimeter, cubic centimeter, and cubic millimeter. Now let's say that we choose to go from cubic kilometer to cubic hectometer. Now we have to multiply by 1,000, and decimal point moves forward over 3 digits. If we go all the way to cubic decameter, then decimal point moves forward over 6 digits. The moves, as before, can happen anywhere on this chart. So we may go from cubic decimeter to cubic centimeter, and we still have to move the decimal point forward over 3 digits. We may choose to go back. If we go from cubic meter to cubic decameter, now we have to divide by 1,000. Decimal point moves back over 3 digits. And if we go all the way to cubic kilometer, then decimal point moves back over 9 digits. Okay, I should also mention, just as with area, that the notation cubic kilometer means kilometer times kilometer times kilometer. It does not mean kilo times meter times meter times meter. All right, so if we want to convert units of volume on the metric chart, we move the decimal point back and forth, and for every move on the chart, decimal point moves over 3 digits. Here's an example. Let's say we want to convert 31,450 cubic millimeters to cubic decimeter. And so the question is 31,450 cubic millimeters is equal to how many cubic decimeters? Now we write the number 31,450. Decimal point is associated to the unit that's given, cubic millimeters. And then to go from cubic millimeter to cubic decimeter, we have to move to the left. First, we go from cubic millimeter to cubic centimeter. Decimal point moves back over 3 digits. Then we go from cubic centimeter to cubic decimeter. Decimal point moves back over another 3 digits. Now we don't have enough, so we're going to add a 0. And add a 0 also before it. Decimal point ends up here then. And we get 0.03145. We can drop the end 0. Okay, problem 2. Convert 0.000214 cubic meters to cubic decimeters. Now this time we have to move forward over 2 places from cubic, apologies. We need to move to the right over 1 place on the chart. And that means that the decimal point has to move forward over 3 digits. So we write the number part. As usual, we associate the given unit to the decimal point. So that's where your cubic meter is. And then we go to cubic decimeter, and decimal point moves forward over 3 digits. We end up with 0.214. Okay everyone, thank you so much for watching. Now there are certain conversions in SI that I will talk about in future videos. Those are conversions where there is a lot of units being multiplied and divided. We'll talk about all of that in some of the videos that I will make in the future. And thank you as usual for watching this video. I wish you all a great day, and until the next one,